Uh, my presentation is a novel predefined time ZNN model for time-dependent matrix inversion. I'm from Hunan University. The structure of my presentation is divided in 4 parts: introduction and then problem description, model design, example verification, and a summary. Solving the matrix inversion problem is an indispensable and significant step in scientific research and many problems. So it's widely used in science and engineering. The exact solution of the matrix inversion help us to gain insight into the physical principle of motion. The boundless is a creation criteria to judge the stability of the solved method and is directly related to the accuracy of the resulting solution. So the fast convergence speeds, high accuracy, and excellent robustness of the method for solving the matrix inversion problem have been the goal of the research. Up to now, a variety of iterative numeric methods have been used in solving matrix inversion problem. Although the iterative numeric method has achieved an outstanding consequence, there is a high computational complexity when dealing with not
we have lost your sound. Sorry, please repeat. I think last sentences because we didn't hear you. Okay, we have some technical problems with connection. We still don't hear you. Please check your sound. Well, if you hear me, maybe you will disconnect, switch Zoom off and connect again, please. Maybe connection will be more stable. We don't have sound. Well, we still have problem. I have written to presenter in chat. I don't know if he hear me. Okay, I will try to disconnect you. Please connect again. Otherwise, we can't hear you. Please, anybody write in chat. Do you have the same problems as me? I don't hear any sound. Oh, yes. Okay, I will stop connection with Lin Xiao. Please reconnect again. Maybe we will get better connection. Okay, we will wait.
of the problem. Thus, the concept of predefined time convergence is proposed, which allows model to achieve predefined time convergence. Regrettably, the delusion ability of the most zero neural network model using this predefined time convergent activation function is not appreciated, and sometimes it causes model failure in the presented of noise. Therefore, in order to overcome the boundaries of the pre-time convergent model, a law of activation is defined by us, which is named fast defined convergence activation function. This function can accelerate the convergence without greatly increasing the time complexity. This function achieves a qualitative leap in both the boundaries and the convergence. Based on this fast-defined convergence activation function, we proposed a complex-valued fast-defined zero-in neural network model for complex-valued time-dependent matrix problem. Now, let's see the problem description. In mathematics, the general form of complex value time-dependent matrix inversion problem can be written as equation 1, where X represents the unknown complex matrix, which is the solution to the equation. I is the applicable size identity matrix. They stand for the given time-independent coefficients matrix, and T represent time. In the present study, ZT is assumed to be a non-singular matrix. Therefore, purple one has unique solution. This part may talk about the design process of the model. First, combine the purple one, take their knowing neural network conventional design method as the basis, where time dependent error fraction ET is defined as equation 2. But in this work, a lower time independent error fraction is designed as equation 3, which is different from equation 2. Afterwards, the design formula for general error fraction is given as equation 4, which is for complex valued field. Well, if theta is a design method that regulates the conversion rate of this conventional zero-in neural network model, I stands for the imaginary parts. AT and BT are the real and the imaginary parts of the error matrix ET, respectively. And F represents our nonlinear activations. Substitute 3 into 4, the following initial ZNN model can be obtained. That is equation 5. Besides, it's inevitable that various noises exist in the process of solving the CVTD matrix inversion problem actively. So the conventional zero neural network model for this case of noise beta T interference is taken into account as follows. That is equation 6. Beta is denotes noise interference. As we said before, the active function has a critical effect on a neural network model, especially for the performance about convergence and the boundaries. One of the core contributions of this paper is the design of excellent predefined time convergence active function. That is equation 6. In this equation, where W1, W2 are equal a great theorem, and psi is defined as sign function. In this novel predefined convergent activation function can achieve a qualitative leap in both the boundaries and the convergence for CFPZ model. Also, we choose the following widely used exact activation function for comparison. One is linear activation function. 2 is power activation function. 3 is sine B power activation. And the last one is predefined convergent activation. In this presentation, no theory are presented. Please see more details. Can be seen my paper. Next part is example verification. In the above parts, allow neural network model and 5 active function are presented. To further demonstrate validity and superiority of this model, some illustrative examples are presented, and the corresponding computer simulation results are provided to prove the effectiveness and the superiority of the proposed neural network model. The following time-dependent invertible matrix is selected to verify the validity of CFPZ model for complex valued time-dependent matrix inversion problem. And we can compute the following theoretical inverse of the matrix ZT. Without loss of generality, the following design parameters are set in this experiment. First of all, in figure 1, the blue will show the trajectory of theoretic solution and a state solution computed by the proposed neural network for the above example, where the blue solid and the red dashed lines represented the evolution of the neural state solution generated by CFTZ model and the theoretical inverse of the matrix ZT, respective. From this figure, we can see that the neural state solution can repeat the theoretical inverse gradually and accurately. For comparison, several used activation functions are also applied in this model. At the same time, noises polluted environment and the excellent convergence of the FPCAF is strongly demonstrated. In addition, a set of comparison experiments are conducted from the boundaries point of views about in the absence of noise, consistent noise and sine noise disturbance, respectively. In this fake CFP model and the CM model using linear activation function, power activation function, Sandy power activation, and the peak-time convergence activation are used to solve the same above problem. See from the simulation results shown in this figure 2, the behavior of result error gradually adjusts down, and it's worth mentioning that the convergence time of the result error of the proposed model is the shortest, about 0.3 seconds, while the other active function take much time to make the result error converge to 0. Besides, two different types of noises, including constants and sine noise, are considered. Figure 3a demonstrates that the result error about the proposed active function involving converges to 0 much quicker than other 4 other activation functions involving under the noise disturbance of beta equals 0.1. Similarly, in figure 3b, in the case of the noise disturbance of beta equals 0.1 cosine 0.5t, the conversion rate of result error to 0 is also the fastest. In other words, the proposed model has the best boundaries. It's noted that the proposed activation function has a new parameter W1, which is at the heart of its excellent predefined convergence. We set W1 at 1 and 10 respectively for comparison. The experimental results are shown in figure 4, which prove that increasing the design parameter W1 can further accelerate the convergence speed of CFP model. Last one, the summary. In this paper, a novel model called complex valued fast predefined zeroing neural network activated by a novel predefined convergent activation function is first designed for a complex valued time-dependent matrix problem. Unlike traditional neural networks that can only solve a time-dependent matrix inversion problem in a noise-free environment, the proposed zeroing neural network model can supervise the noise interference in the process of obtaining the inverse of complex time-independent matrix. In addition, compared to existing classic activation function such as linear active function, power active function, semi-power active function, and the peak-time convergent active function, the proposed active function performs superior in terms of boundaries, and the proposed zeroing neural network model have this excellent performance and meets the requirement of the predefined conversion time. Finally, the experience results of computer simulation further prove the effectiveness and the superiority of the purpose model for complex valued time-dependent matrix inverse problem and the lowered FPC activation faction. That's all. Thank you very much. Thank you. Thank you.
Okay, thank you very much. We have some technical problems in the beginning, but nevertheless, if anybody have any questions, please.
Can I make a question?
Yes, please.
Professor Xiao, can we generate the results in the solution of time-varying recurrent equations? Professor Xiao? Can you hear me? Can you hear me?
Well, we still have problems.
Professor Sop, can you hear me?
Yes, I hear you.
Okay.
So I think
I will write in the chat if we see it's okay. Okay.
Okay. Well, I think we can stop here. We have finished our first part earlier, so it means that we have now big break. We will continue our next part, the regular session with regular papers in 18:30 Krasnoyarsk time. So we have an hour to have a rest.